Okay, question number 3. It is given that alpha plus beta plus gamma plus delta is equal to 2. Alpha square plus beta square plus gamma square plus delta square is equal to 3. And alpha cube plus beta cube plus gamma cube plus delta cube is equal to 4. Now basically this is referring to the recurrence formula where we have Sn is equal to alpha to the n plus beta to the n plus gamma to the n plus delta to the n. So basically now what we see, this is 3 here, so this is our S3 turns out to be S2 for this one, and this is S1. We need to find the value of alpha beta plus alpha gamma plus n. So all of that here is what we deem to be the sum of alpha beta. And to be able to get the sum of alpha beta from the recurrence formula we know that S2 is equal to S1 to the square minus 2 alpha beta. So if we rearrange this formula, it's going to become sum of alpha beta, which is then is equal to, so this goes on this side, this comes here, so S1 to the square minus S2, and all of that being divided by 2. So S1 to the square we know is 2 to the square minus S2, and S2 has been given as 3, and so we divide this by 2. So then we have sum of alpha beta is equal to 4 minus 3 divided by 2, which is then half. So that's the first part of the question. Now for the second part, we have to find the value of alpha square beta plus alpha square gamma plus alpha square delta. We can see alpha square, alpha square, alpha square. So that can be factored out, and I have beta plus gamma plus delta. Then the same goes for the second one. We have beta square, beta square, beta square. So plus beta square into alpha plus gamma plus delta. Plus next we have these. And so what can we make out of all of that over here? So beta plus gamma plus delta. If we go back to part 1, so beta plus gamma plus delta is here. So this alpha can go on the other side, becomes minus alpha. So that's going to be 2 minus alpha is equal to all of that 3 over here. Okay, so let's try and see now if we try to do this over here. So this is going to be 2 minus alpha, and the same goes for the other ones, which then becomes all of that. And if we now distribute whatever is outside inside, so that's going to be alpha square times 2, which is 2 alpha square minus alpha cube plus 2 beta square minus beta cube plus all of that over here. So now we can factor further. We have 2 alpha square, 2 beta square plus 2 gamma square, which is 2 into alpha square plus beta square plus gamma square. Then I've got minus alpha cube, minus beta cube, minus gamma cube, minus delta cube. So this is what we have now. And if we look at alpha 2 plus beta 2 plus gamma 2, it was given in the question as 3, and this one was given as 4. So 2 times 3 is 6, 6 minus 4, we get 2 over here for the second part of the question. So that's the answer. Now for the third part of the question here, we need to find, we've given this equation here, and we're told that alpha, beta, gamma, delta are roots of that equation. So again, we're going to be using the recurrence formula, and so we have then S4. So all of that is actually S4. And what is S4 in terms of this equation here? It's going to be equal to 6S4 minus 12S3 plus 3S2 plus 2S and plus, now this 6 here, we have 4 over here, so it can be 6 times 4, which is then 24, and all of that should be equal to 0. Now from here we can rearrange this equation and make S4 the subject formula, which then becomes all of that. And so now what we just need to do is just substitute in the values. So 12, S3 was given as 4 minus 3 times S2 was given as 3, and then minus 2 times S was actually 2, and then minus 24, and all of that would be then divided by 6. And we end up with 11 over 6, so that should be what is needed for this part of the question. Moving on to part 2 of the final, we need to find alpha to the 5 plus beta to the 5 and so on. So again, the recurrence formula comes into play. So we just need to copy down the equation first, which is what we have been given over here as such. Now using the recurrence formula, we have 6s to the 5 minus 12s4 plus 3s3 plus 2s2 plus 6s. And all of that is equal to 0. And again, now we're going to be rearranging this and make S5 the subject formula. And this is what we get after we make the arrangements. So we just need to substitute the values in now. S4 was found to be actually 11 over 6. And this is pretty much what we're expecting here. So S5 is going to be equal to, so from our calculator we're going to get S5 as minus 8 over 6. Simplifying further, this turns out to be minus 4 over 3. And here we are for this complete part of the question. I mean, this whole question over here. Okay. Thank you.